Hi everyone, welcome to C Studio's Raspberry Pi Day project sharing. I'm Jenna, marketing manager from C Studio, and I'm so excited to have you all here today with me to celebrate the Raspberry Pi Day this year. Before we dive in, let me give you a quick introduction to C Studio and our partnership with Raspberry Pi. Since 2013, C Studio has been deeply involved in the Raspberry Pi ecosystem. We are proud to say that we became approved reseller and design partner of Raspberry Pi in 2018 and 2021, respectively. At C Studio, we offer a wide range of IoT devices based on Raspberry Pi, including routers, gateways, and HMIs. Plus, we provide comprehensive custom design and manufacturing services from PCB prototyping to mass production and shipping. We have been serving customers and partners from various industries like smart buildings, agriculture, healthcare, energy management, and so on. Our Raspberry Pi-based solutions keep empowering them to upgrade the devices and the services at the edge. Okay, let's get into today's topic. Today in this event, we've got 4 fantastic speakers lined up, each ready to share their passion and inspiration with Raspberry Pi. They are Karen from HashiCorp, who is serving as a senior developer advocate at HashiCorp for infrastructure and orchestration. Now, let's kick off today's Raspberry Pi adventure together.
Good morning, good afternoon, and good evening. Thank you for joining me today from wherever you're joining me from. I'm super excited to show you something we're currently working on and having a lot of fun with. First, allow me to introduce myself. My name is Karim Satili, and I work at HashiCorp as a developer advocate where I help people figure out best practices around infrastructure and orchestration tooling. Before joining HashiCorp, I worked at the Amsterdam airport on industrial IoT projects, primarily around LoRa. If you have any thoughts about this demo, you can find me as @ksatili on pretty much any network. So let's talk about edge computing for a minute. The dictionary definition of edge compute is computing that takes place at or near the physical location of the producer or consumer of data. And the physical part here is what's really important for today's talk. Way before we had edge compute in the way we think of it now, around the beginning of the 1990s, many points of presence for a web hosting company or a content delivery network were considered an edge location. But we're not here to talk about the old stuff, are we? We're here to talk about the new stuff, batch computing. That is, computing that takes place on your conference badge, supported by a single board computer, an e-paper screen, and maybe a handful of sensors. So let's talk about what brought us here and how we can go from inspiration to a design and from analog to digital. Imagine you're at a real-life conference right now, not behind your computer or phone watching the stream. We'll call our event Pi Day Conf. Same speakers, same content, but in person so we can celebrate today's date and all the amazing change Raspberry Pis have brought us over these past 12 years. And just to give you an idea of what I'm talking about, this is what the badge you'd get at registration would look like. Lanyard at the top to wear around your neck, your name, a QR code, if you want to connect with the other attendees, and of course the type of badge, such as speaker, organizer, or attendee. So a conference badge. Nice, easy to print, easy to replace. Also completely analog, no fanciness, no nothing. Let's see what we can do about that. We'll keep the conference branding, of course, because color displays are expensive. And then let's replace the printed name with a low-powered screen. And the outside heavy stock paper, let's replace that with a plastic frame we can relabel every time we use this badge. If we flip it over, we'll see that all of this is powered by a Raspberry Pi Zero 2W. So, a fully powered computer, 4 cores, totaling 4 gigahertz of CPU power, 512 megs of memory, 40-pin GPIO interface, Wi-Fi, and Bluetooth. That is a pretty sweet development platform. And we'll install HashiCorp Nomad to run some of the software we need for the badge. And of course, we'll connect a battery shield to make sure we can power the badge. So front and back together, we get this view. And that brings us to the next part. What is it that we actually want to show on our badge? Well, we definitely need our name and QR code on the badge, right? That way people can connect with us and the venue can check that the badge is legit. We can add other things here, such as our job title or a social media username. I like to call this the wearer screen because it shows information about who's wearing the badge. But there's no reason to stop at just one screen. The system supports an almost infinite number of screens, and we can draw whatever we want on a screen as long as we can calculate the shape. But before we go down that rabbit hole, let's add 2 screens that allow us to see what's going on. On the left side, you see the Nomad screen. This screen shows us the version of Nomad we're running, what IP address it is running on, and some other information. Remember, the Pi 02 has built-in Wi-Fi, so we can actually talk to the badge through a browser, through curl, and through other tools. And on the right side, you see the badge screen. Right now, this only shows us the e-paper hardware we're using. So in our case, it's a 2.7-inch model, revision 2. And of course, we might add more useful information here in the future. But for now, that's a start. And maybe if you have ideas, share them in the chat. Maybe we should add the number of screens we have available or list all the screen names. There's countless options that we haven't thought about, but if you have an idea, let us know. So now that we know what we want to have, the question really is, how do we make our design a usable prototype? Well, we started out with a Pi 02W, and then we connected an e-paper screen to it. E-paper is absolutely calming technology, it's kind on your eyes, way less distracting than a full color display, but an e-paper screen without software does nothing. So we switched to our code editor and started writing some code. The library we use is Python-based, so there was a lot of code to write. Now, like a lot. I really mean it. And we went even deeper into the rabbit hole and built a web server into it. And if you're wondering, yes, this is the actual code we use for this application. So upload the code to the Pi 0 and then run it, and we get to see our first screen. We filled some more, built some more screens, and before you know it, we had our application code ready. And that's it, right? We're done here. We wrote our code, we're driving a screen, and wait, no, actually we're not. My code is not super good, keeps crashing, so I'm gonna need some help. I need an application that can help me figure this out. And you've heard me mention Nomad a few times, so let me give you a quick explanation. Nomad is a freely available workload orchestration tool that's built by HashiCorp. Nomad can run anything from container images to Java application. It works great with Minecraft and even Windows binaries. And Nomad can do so at a scale that works for companies like Roblox and Epic Games, but you don't need a huge data center for this. Nomad can run anything, but also anywhere, including on a Raspberry Pi 02, which is what we're using. So let's switch back to our code editor, and I'll quickly show you how to wrap our Python application so Nomad can handle the execution of it. We'll start by defining some meta information, such as where we want to run this software, and because we know we need specific hardware like an e-paper screen, you can see I'm targeting a group that is called badges. And next, I'm mapping a port for the web server we built to make sure I can access it via my browser and via curl and via my API client. Then, of course, there's some more configuration in environment variables, like where to get the name and link from the QR code from, and a couple of other things, such as the exact port I want the Python application to start on. So with all that code done, let me connect to my read terminal and show you how this looks like. Before you ask, no, the badges don't need the read terminal to run. They can absolutely run standalone just on the Raspberry Pi 02. But when you're building a whole network of these badges, we're currently up to 7 prototypes, it is nice to have a device master that can take care of all the edge devices. And so that's where the read terminal comes in for us. So we'll open a Nomad UI where we can see one primary server, our read terminal. I'm running this on Chromium in full screen mode on the device, so sometimes you'll see a mouse cursor when I tap something on the touch screen, and sometimes you won't see the cursor. So we're starting out on the Servo view, and this is our device master, the read terminal. And if I go into settings, you can see that the read terminal is healthy. You can see the data center we're running in, it's called Edge. And if I click on clients, you can see we're using 39 out of our 4,000 megahertz. We're using a third of our memory, and it all seems to be looking fine. But of course, if you have one of these badges, or maybe even 10, how do you deal with updating it? We have a smart badge in the sense of it's cool hardware, but the hardware itself doesn't yet know what we want it to do. So we're going to use a feature in Nomad called Nomad Actions, which allow us to run small scripts or small actions, hence the name, on the badge directly. And I'll give you a quick overview of some of them. So at the top, we have the right screen action for badge, which will show us what hardware version we have, and so on and so forth. Next up, you'll see a couple of familiar names. The Nomad screen, of course, gives us Nomad information. The wearer screen shows who's wearing the badge. And we also have an option to clear the screen. This is important because sometimes we mess up drawing, and then we want to easily be able to reset the screen without having to connect to the badge directly. And then, because it's a Python application, we might have some changes. We might have some changes remotely in the Git repository, so we can fetch those changes, reinstall our dependencies, or even just print out the whole badge environment for debugging purposes. But of course, the Nomad UI is not the only way to access this application. We also have a built-in web server, which we can talk to through curl, which is what those Nomad actions do, or if you are so inclined, you can use a very minimal UI that allows us to interact with the hardware a bit. So I can get the status of the API, which seems to be okay. I can list out all the routes that are available on the server, and I can query the screen status. But that one is not very deterministic because the underlying library doesn't support everything we need, so we make a best guess effort. And now that we have the software side and the hardware side figured out, let's have a look at how it looks like when we put it all together. If you remember, we started out by defining a wearer screen. And fully implemented without any conference branding right now, the real screen looks like this. All these values are populated from the Python application. And yes, we can adjust the size of the font. We wanted to see how far down we can go before it stops being legible. I think we found that sweet spot. And then, of course, we also have the Nomad screen and the badge screen. And you'll see on the left side, we're populating the allocation ID, we're populating the IP address that we need, we're showcasing the version of Nomad that we're running, just to make sure everything is as it should be. And on the right side, we have a vanity screen just showing the badge branding and a URL you can go to if you want to check out the source code. Of course, hardware is a good first step, the software looks good, so next step for us is really figuring out how we're going to make this look like. And in the interest of time, I'm just going to show you a real quick preview. This is the initial design that we have. We're cutting up a couple of different badges and basically making sure the display fits and figure out the best sizing and then create templates for that for different screen sizes with different plastic frames that you can easily insert this into. And then, of course, make sure everything is available on that URL that you saw earlier that we'll share in a second again, just so we all can have some fun with this. And with that, I think my time's almost up. So there's only one thing left to tell you, which is if you want to check out the code that we use to build our version of a conference badge, head on over to github.com/workloads or scan the QR code that's shown on your screen right now. We maintain this complete code base that's needed to build this. We have the Nomad code, the Python code, and of course, a bill of materials so you know what hardware to order. Thank you for having me. My name is Karim Satili. I hope this was fun and educational for you. If you have ideas, if you want to collaborate, find us in the comments, find us on GitHub. Leave an issue and let us know what you want to be doing. I think the next thing we're going to be working on is fingerprint scanning and then loading personalized badges based on who scans their fingers. But maybe you have crazier ideas, maybe something even cooler. Let us know. Thank you.
The second speaker is Gabriel, who is an IoT specialist for control and communication.
The number of IoT devices grows every day, generating a lot of information. This information can be used with the help of the AI for finding new solutions for problems in our communities and the environments. Now, from children to adults, they can learn how to make technological solutions in an easy way, thanks to the open source platforms like Raspberry Pi, IoT hardware enablers like C Studio, and Python for coding. They are promoting the innovation around the world by bringing this technology into our hands. I am Gabriel Cuello from Ecuador. I am IoT enthusiast and professor. Today, I want to show you some examples of projects that use all this technology. I'll talk about some projects like interoperability between Raspberry Pi and Arduino Cloud, conveyor belt analysis, six-wheeled explore robots, and finally, I will give you some tips for IoT development when you are using Raspberry Pi. Let's start. This project shows the interoperability between Raspberry Pi and Arduino Cloud. When we develop a solution, we have many options for sensors, platforms, outputs, and clouds. Then it's important that all these components work fine between them. In this case, we have a Raspberry Pi 3 like a platform. Then we connect this to a C Studio BCO2 sensor in order to get information about the concentration of gas in the environment. With this information, when the parent is too high, the concentration of the gas is too high, we turn on a fan in order to getting a fresh air into any area, like a room or any purposes. All the information generated here is sent to the Arduino Cloud in real time. Let's watch how it works. Now we have all the components connected between them. In the center, the sensor. You can see some dashboard here. This is the Arduino Cloud, and you can see the information in real time using a web browser or a cell phone. This is a great help. Now, get some fire here. As you can see, the information is sent to the cloud in the real time. This information is processed and stored in this cloud, and you can use in different ways. The dashboard is an easy tool, and you have many options for present the information, and you can use so many variables or parameters here. This help gives you opportunity to develop a solution in a short time and low cost. My next project is a conveyor belt analysis. In this case, I have two parts. The first part, take a video from the belt in order to see if this in movements or if this have objects on it. We use a camera connected to Raspberry Pi to process the video using an OpenCV library. With this information, we can have report of the time that the bell is working with objects. It is useful for know when we need to put more objects or when we need to turn off the belt. The other part here is the speed control for the belt. In this case, I am using a Studio Bio terminal. That is other platform for develop IoT projects. Now, let's see how it works. As you can see, the belt is stopped. In this part, we see the video taken from the webcam that is processed by the Raspberry Pi. Remember that we are using algorithms with OpenCV libraries and Python for coding. Now let's start the belt. You can see the state change to movement and is counting how many elements are passing on it. This is other form to use. In this case, is only analyzing if it's empty or if there are elements. This is the last project that I want to show you today. It's a 6-wheeled explorer robot. I made this robot using recycled materials. The design is taken from Mars explorers, and it has a good stability under many conditions. This project has two parts. The first part is a remote control and camera. That means that I am using a Studio Xiao XP32 Sense system on chip. This is useful for many projects too. In this case, take the command from an app. This app was made using Meet-app Inventor and was developed by my son, who is 13 years old. As I told you before, from children to adults can handle this project. The other part where I use the Raspberry Pi, in this case, is a general purpose sensors. That means that this robot is a base for other projects. In this case, the robot provides an energy for the Raspberry Pi, and we can use for many purposes using sensors, camera. Later, I will connect some of these sensors, but now let's watch how it works. Now I want to share some tips for IoT solutions. Let's check some basic components. The devices are made with some platforms like Raspberry Pi or Arduino on SP32. They have sensors. The sensors get information for the environment like temperature, video, and other many values. At this moment, there are sensors for anything that you can imagine with a low cost. Other thing that we need is to take actions in the environment. Maybe open a door, turn on a fan, turn on lights, etc. And we have many actuators for this. Other important part is the connectivity, because we need to send the information to the cloud. This connectivity, there are many options like Wi-Fi, cellular networks, LoRaWAN. There are many options. In the cloud, there are many options too, like Arduino Cloud, Azure, AWS, etc. All the information that we receive from the device, that can be many hundreds or thousands of devices, are taken, processed, and storage in the cloud. After this, we can see the information without using dashboards. Have a graph for see the information in an easy way, and it helps us for make decisions. Other component here is the AI. AI can get more information about all data that you can get. All these components work together for solve a problem or any other objective that you have. Normally, if you have any problem, you want to optimize the use of the resources like water, electricity. When you optimize the use of these resources, you save money. Other thing that we shouldn't forget is the security. All this data must be only known by the owner, by anyone outside of the company, home, community must to know what are the information here, because they can use in bad way, or they can maybe take your device and use for bad purposes, or maybe use the actuators and makes damage in your solutions. Because of that, is really important. Let's check some tips for IoT development using Raspberry Pi. Raspberry Pi needs a lot of energy. For this, needs a good power supply. That is really important, especially in applications that are far away from urban areas, or si you have a land robot, you need at least 2 amps in the power. For the robot, we need to take the power supply in different way from the motors. That means that you need a power supply for Raspberry Pi and other power supply for the motors, because the energy taken for the motors can restart the Raspberry Pi. Other important thing is take care of the connections. If you are making a prototypes, you need to use good cables. The best solution is solder the cables. Other thing that I use a good enclosure. The environment, the humidity in the environments normally can damage the electronic components. Then you need to have a good enclosure for solve this problem. Other one is take time to understand the problem. It's not only the problem that the client or the community see or feels. We need to, in deep analysis, find the origin of the problem. In this way, we can make a better solution for this. Other important things is select carefully the components using the last version. That means we need to try to get the last version of the hardware, the last version of the software, because it solves problems like security. It's as I told you before, the security is really important because this data needs to have confidentiality, integrity, and disponibility. Finally, select a strong IoT hardware enabler is important. You need to have components on time, components with a good quality, variety of sensors, platforms, good documentations, and a good price. City Studio is the best choice. Okay? Thank you for your time, and I want that all this information will be help you for your projects.
Our third friend will be Hendra talking. He's an educator at universities in Indonesia who teaches computer science.
Okay, so in this video, I'm gonna briefly explain about one of the project that my student is working on that I help him supervise with. This is the Valve Servo tester dashboard. So you can see this is custom made by him alongside with the place where he's working. He's adding a Raspberry Pi on top of the case alongside beside the generator. This is the generator. And this is the block diagram of the project. So you can see this is the servo. This is how the testing is working, which is the input, and then there's the process, which will be read by the Raspberry Pi 4B, and then there's an output, which is in the form of the GUI. This is the full project, the full case. As you can see, they are pretty minimal, but this is what the industrial needed at the moment. Because before, the software is only running on a Windows-based system, and you cannot do it with any other operating system other than Windows. So he's making this solution so he can make the device, the tester device, as compact as it can be. Now we are going to test the normal servo tester. So there are, the servo is already connected from this cable, and we're going to try to send a command, a signal, some kind of signal from the generator through the servo. Yeah, and then the Raspberry Pi is already connected. And as you can see, there are two dashboards in there. There are two meters in there. The left one is the command, which is given to the servo. And the right one is the servo feedback. As you can see, this is running normally. Both the left one and the right side and the right one is simultaneously giving the same number. So if there's any anomaly or if the servo is broken, the right dashboard will pointing out differently from the left one. And this one is normal, so as you can see, everything running as it's supposed to be. The LCD used for this project is regular 14 or 17 inch, I forget. Okay, so there's also another feature that he's adding, which is the graph feature, the graph dashboard. So these two lines, actually there is two lines in here, a green one and a blue one. Both of them are moving harmoniously. I can't find the word, but they're moving together, which means that both the command and the signals are running perfectly. Now for the next one, we're going to test with a broken valve. So this is the valve that is broken, the servo valve that is broken. Now we're going to do the same thing as before. As you can see, the right one doesn't follow the left one, and that indicates that this servo is not giving the right feedback, and somehow the servo is not moving accordingly. Indicate that it is broken. Now we will check on the graph one. As you can see, those two lines doesn't move simultaneously, and this is indicate that the servo is broken. Yeah, so the conclusion of this project is actually to make a device that is portable enough to be carried around, and it could be taken to some factory or some industrial factory, and they can check the servo directly, and no more Windows laptop are needed, because it will be so bulky before, and because of this project, it will eliminate the necessity of bringing a bigger device to the factory only just to test the capability of the Valve Servo. So yeah, that's the brief introduction of my Raspberry Pi project, and thank you.
Moreover, our application engineer Kasum will also share his recent demos and related to C Studio's Raspberry Pi projects as well.
Hello, my name is Kasun. I am an application engineer at C Studio. Today, on this Pi Day, I will demonstrate a solution for car parking system using our Pi-based products. Before moving on to the demonstration, I would like to introduce the hardware preparation of this demo. The hardware I am going to use includes reterminal, reterminal DM and the Pi camera. Reterminal is a versatile palm-sized Raspberry Pi powered HMI with rich I/O peripherals. It features a 5 inches IPS capacitive multi-touch screen, Wi-Fi, Bluetooth, USB, Ethernet, sufficient eMMC storage and built-in sensors. This device is more suitable for home automation, personal assistant dashboards, robotics, kiosk, and various edge and other IoT applications. In this demo, I am going to set up this device in my car park model to count available parking slots. Next, I will introduce an industrial grade HMI. It is not only functions as an HMI but also it can act as IoT gateway, panel PC and sometimes even a PLC with its I/O peripherals. It supports various wireless connections such as LoRaWAN, 4G LTE, Wi-Fi and BLE, as well as industrial protocols like RS-485, RS-232 and Ethernet. This device has an IP65 rated front panel and 10.1 inches size. In this demo, I am using this device as an end device, demonstrating parking slot count output concerning the time of the day in user-friendly manner. Let's assume that this device is located in the building connected to this car park. Finally, we have the Pi camera, which is connected to our reterminal device. This is used to capture the video feed of the car park. While this may not be the newest camera, you can find the latest Pi cam on our marketplace. Next, we will move towards the demo. In my car park model, the video feed is connected to the reterminal. I have created a custom dataset and trained it using TensorFlow Lite. As you may be aware, for Raspberry Pi we cannot deploy heavy models, so it's necessary to quantize them. After creating the model with TensorFlow, I converted it into TensorFlow Lite model and deploy it on the reterminal device. The model used here is efficient date model, but you can also try out YOLO v5. Our wiki provides instructions on deploying YOLO v5 with your own custom dataset and detecting objects with pre-trained COCO dataset using efficient date. Without hardware acceleration, the experience is around 6 to 7 FPS. However, if you connect USB TPU, you can expect performance boost to around 19 to 20 fps for 224 by 224 input image. The output of the model, which represents the number of available parking slots, is sent to the AWS cloud. If you don't have an account, you need to create one and generate certificates, private keys, public keys, and root CA file. After inserting these credentials to the reterminal device, it will be able to communicate with AWS IoT Core. I utilize the PAHO MQTT library for this communication. Using an MQTT test client, we can easily inspect the payload, and you can observe that the connection is successfully established. We have created a step-by-step wiki explaining how to establish an MQTT connection between our devices and AWS IoT Core. Next, I will subscribe this data to reterminal DM. Neuron serves as a comprehensive industrial edge platform for IIoT and data ops. It allows you to create visually appearing dashboards with data pipeline connected to cloud, supporting MQTT, Modbus, OPC ADA, and other industrial protocols. In this demo, I need to set up a module for MQTT and AWS connection within Neuron. Then I created a tag to capture the data. Once the credentials are provided to Neuron to subscribe to the data, we can explore and confirm that connection is well established. After subscribing, this data can be visualized. You will be able to observe variations in the car park slots over time. We have created a step-by-step wiki that explains how to start with Neuron, covering installation and creation of web UI. Now let's take a look at the big picture. Since this is not the time constraint object detection problem, I have deployed parking slot detection on reterminal using TensorFlow Lite. Next, we need to provide the credentials to IoT Core. In the edge object detection, the final output will be published to the cloud from reterminal. Then reterminal DM located in another place subscribe to this data and creates a user-friendly interface using Neuron. Step-by-step guidelines for these processes are available on our Knowledge Sharing Center. You can find more topics like IIoT, TinyML, Home Assistant, SCADA, PLC, etc. etc. If you are interested in our products, you can visit on our bazaar as well. Subscribe our blog and we will provide you latest updates. So stay tuned. Bye bye. Happy Friday.
Thank you all for joining us today, and a huge thanks to our speakers for sharing their incredible Raspberry Pi projects. You can also click the link down here to know more about SysStudio's Raspberry Pi ecosystem and talk to us. Stay tuned for more exciting events from SysStudio. Until next time, take care.